Oh, you've won many medals, yes?
Yes, I have.
Oh, but no world record.
No, not yet.
And that is what you want to ask the cars.
Wow, that's amazing. That's what I came here to ask you. When will I break the record? Yes. Yes, I see it. What? Well, tell me.
I see negative 1.17 over 10.
What does it mean?
Oh, it could mean many things. The cards are very mysterious. That'll be $5, please.
Sports figures. Put your brain in the game.
Actually, we can predict when Marion will break the world record. We just can't do it with these.
You just have to figure out the slope. Woo!
To help us figure it out, we've got Marion Jones. She won 5 medals at the 2000 Olympics in Sydney, so she could be breaking the world record any day now. Marion, it must have been amazing to win all those medals.
Yeah, it was an awesome experience.
Well, let's make it a prediction about when you'll beat the world record time.
Okay, it sounds good.
Okay, let's try the 100 meters, for example. What's the current world record?
Well, Florence Griffith Joyner ran 10.49 seconds in 1988.
Wow, 14 years and no one's beaten that record?
Well, that's a pretty hard time to beat.
Okay, well, let's figure out when you're gonna do it.
Okay.
Ooh. Okay, guys, how are we gonna figure this out? I don't know. Oh, come on, it's not that hard. Look, I'll give you a hint. It has to do with the progression of Marion's times.
Maybe we can make a chart or a graph of Marion's times.
Yeah, then you would want her times and the years to see the progression.
Yeah, that sounds like a great place to start.
Yeah.
When you graph something, you use a Cartesian graph, like this. And you label each of your axes X and Y. Each axis represents a different unit of measurement, so one axis might represent speed, and the other axis might represent time. You put points on the grid that represent where your numbers fall. That's called plotting. When you put your information on the grid, you plot your numbers. Plot. Oh, but before we can plot anything, we need to get some numbers. Okay, Marion, we need to get some 411 from you. When did you start first running seriously?
Well, it must have been 1989. That's when I kind of started first keeping track of my times.
Okay, so let's go back to then. What was your best time for the 100 meters back then?
In 1989, I ran 12.01.
Okay. In 1990?
11.62.
In 91?
11.17.
92?
11.14.
93?
11.28.
94?
11.28.
Huh. 95?
Well, in 95 and 96, I kind of had a foot injury and couldn't run.
Oh, okay. Well, let's skip to 97.
All right, 10.76.
Wow, you recovered pretty well. All right. 98?
10.65.
Okay. 99?
10.70.
And then in 2000, you won the Olympic gold. That must have been your best time ever.
Well, not quite. I ran 10.75.
Oh, okay. And how about since then?
Well, in 2001, I ran 10.84.
All right. Some ups and downs, but right away we see a progression of faster and faster times.
Well, that's the plan.
Okay, so now we have our numbers. Now what?
You have to plot them on a graph.
Okay, but how do we know where to put them?
First, you have to decide which axis of the graph represents years and which represents Marion's times.
Let's put our years on the x-axis down here. We're going to be going from 1989 to 2001. And we're going to include 95 and 96, even though she didn't post times in those years. On the y-axis, let's plot the best times that she ran. Now, you know what? The difference in Marion's times only spans 1.36 seconds. That's a difference in hundredths of a second. If we did our scale in minutes, all the points would be on top of each other. Let's put a scale in tenths of a second. Choosing the units to use on your axis is a big part of graphing. You want the scale to be big enough so you can see what's going on, but you don't want your graph to be huge. Now we can plot Marion's times. We go across the x-axis to 89 and up the y-axis to 12.01. Plotting points is fun. And you just do this for each year and time. Each point represents two numbers, right? This point here represents 10.76 seconds in 1997. That's why we call it an ordered pair, because each number represents each axis, X, Y. 1997, 10.76. Simple, right? Now we have a picture of Marion's times over the course of the years. You know kids' coloring books where you connect the dots and you get a picture? Oh, look, it's a space creature. Or is it a guitar? Well, after we've plotted our data, we can connect the dots to create a picture of Marion's performance. Oh, except for these 2 years where she didn't run.
So what does this picture tell us?
There are a few ups and downs, but her general progression is faster and faster.
Yeah, now, based on this, how can we predict when Marion will break the world record?
Could you just extend the line so that it reaches the world record time?
Yeah, but which part of the line? I mean, if we extended 2001, it would seem like she was going slower. I mean, is that accurate?
No, because in earlier years, she might lose time one year and get faster in the next.
We need some kind of average of the line.
Exactly.
Instead of creating a line by connecting all the dots, we can create a best fit line. A best fit line runs through the general trend of all of our data points. A graphing program on your computer will automatically create the best fit line, or you can figure it out. When we talk about a graph line, we can talk about its slope. Like this roller coaster has a slope, right? And it's pretty steep. Well, we can find a number for slope. Woo! M stands for slope. Y, I don't know, but that's just a letter that they use. And M equals y2 minus y1 divided by x2 minus x1. Now we can find our slope. And it's a lot easier than it looks. Slope is often described as rise over run. See, it's how much the line rises or falls over the length of its run. To find our slope, M, we just need to find the change in y and x. So we just take where we ended up and subtract where we started from. See these little triangles? Well, they're the Greek letter delta, which means change in math. So delta y over delta x means change in y over change in x. Whoa, ouch! By coincidence, our best fit line is parallel to the line connecting the first and last points on our graph. We can use them as our change in x and y. We can see how it works by figuring out the slope of Marion's line. Our last y coordinate is y2, and our first is y1. Same for x2 and x1. Oh, now we just plug our numbers in. A little quick subtracting, and we get m equals negative 1.17 over 12. That's our slope. Now, if we look at it this way, delta y over delta x means the change in y was negative 1.17 seconds over the change in x, which was 12 years. Or Marion's time improved by negative 1.17 seconds over 12 years.
So how do we use this to figure out when she beats the world record time?
You can just extend the line on the graph until it reaches the world record time on the y-axis.
And you can look on the x-axis to see what year it is.
That makes sense, right? If we just extend our line, eventually it'll cross 10.49 seconds on the y-axis. Or we could just use our numbers. We have a number for the slope of Marion's line, right? It's negative 1.17 over 12. Well, we can convert that to a decimal by just dividing. Negative 1.17 divided by 12 equals 0.0975. Well, let's just round that off to 0.10. So now we have our slope. Marion's time is getting better by 1/10 of a second each year. If we want to figure out when Marion will break the record, we just use our equation again. So m equals change in y over change in x. Now we just plug in what we know. We know m, slope, is negative 0.10 seconds per year. The y-axis wants to be when she surpasses the record of 10.49. So let's say 10.48. And we know her last time was 10.84. The number of years is what we're looking to solve for. A little subtraction, and we get negative 0.10 equals negative 0.36 over delta x. To beat the world record, she will have to improve by 36/100ths of a second. X is how many years that will take. We can look at it as a proportion. Negative 0.10 is to 1 year as negative 0.36 is to delta x years. To solve it, we just cross multiply, and we get negative 0.10x equals negative 0.36. To solve for x, just divide both sides by negative 0.10. So x equals 3.6. So in 3.6 years, you'll break the record.
Wow, that's awesome, thanks.
Ooh, and check this out. If we keep extending the line, in the year 2100, Marion will run the 100 meters in 0 seconds. Uh-oh. Amazing! Marion Jones has just run the 100 meters in a record-smashing 0 seconds. 0! What more can you say? Marion, I got some bad news for you.
What's that?
Well, if we continue the slope of your line, in the year 2100, you're going to run the 100 meters in 0 seconds.
Well, that's impossible. For one thing, I'll be 120 years old.
I know, that's the problem. Something's not right.
So what's going on here? We know that Marion can't run 100 meters in 0 seconds, but that's what our line says.
But we're using it to predict what might happen.
You can't say for sure Marion's gonna go faster and faster each year.
So what's wrong with our prediction? What we didn't look at is the difference between interpolation and extrapolation. When you're trying to predict something using graphs, it's pretty important to know the difference between the two. You can look at it like this. Interpolation, inside, like in or interior. Extrapolation, outside, like exterior or out. When we interpolate, we stay inside our data points, the numbers that we know. We don't have numbers for 95 and 96 because that's when Marion was out with an injury. But interpolation of the line that we created using slope would give us a pretty good idea of what Marion might have run. Marion might have run somewhere between 11 and 11.2. That's interpolation. Extrapolation is when we predict what might happen outside our data points. Out there is the great unknown, a mysterious void that we can only guess at. So while we can predict what might happen using extrapolation, there's no guarantee that it will happen.
So does that mean I'm not gonna break the world record?
No, I didn't say that. Extrapolation is just an informed guess that you can, but I'm afraid the rest is up to you.
So does that mean I get my $5 back?
Will you take a check?
No.
Okay, guys, so what did we learn?
That a good way to work with problems involving speed and distance is to make a Cartesian graph.
To find slope, you use the equation m equals delta y divided by delta x. M is the slope, and delta means changing.
You can use slope to make predictions about what happened or what will happen.
And interpolation is when you draw conclusions within your data point.
And extrapolation is when you draw conclusions outside of your data points.
Yeah, and extrapolation is less reliable than interpolation.
Yeah, I got that. You can also use slope to track your own performance in just about any sport. And then you can use that to set realistic training goals. To find out how, visit the Sports Figures website at sportsfigures.espn.com.